So welcome to this edition of Seen and Solved. I'm your host, Tim Pennington. Today we have a special guest, a real problem solver in the world of wastewater, Robin Deal, also known as the Wastewater Whisperer. Robin's here to talk about a very important topic in the finishing industry, which is PFAS. And we're going to talk to Robin about a few topics. What is PFAS? Why are they such a challenge to the industry? And most importantly, how do you tackle them? So let's get into it.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So, Robin, in the whole world of PFAS, how many compounds so far have been identified?
So, Tim, right now, as of August 2024, we're approaching 15,000 compounds that fall under the PFAS, PFOS category. So there's so many, and they're so prolific in everything from our industry of metal finishing to textiles to firefighting foam suppressant, stain repellents, water repellents. They're just everywhere.
And I know it's funny, I was visiting a couple of shops last week which brought up this subject. And, I know, later on we can talk about how these compounds got into their system. But one of the finisher who was pretty experienced in the industry was telling me that, a lot of these were in mist suppressants, right? And a lot of the chemicals that were used decades ago that were actually mandated by the EPA to use these mist suppressants. And then, this is how it got into some of their tanks. But it's kind of ironic that this was a mandate from the EPA and now they're being held accountable for them. But yeah, you're right. There's just lots and lots of this, but it really is something that's top of mind with this industry. So let's narrow it down. Like I said, we talked about there's ungodly amounts of these things that could be considered a PFAS. But what are the real, the 5 compounds that the EPA has identified and put limits on it for drinking water?
So right now there is PFOA. Drinking water limit is currently 4 parts per trillion. And this is one that's kind of interesting, right? It was used to manufacture Teflon, grease-resistant paper, so like your Domino's pizza box, they didn't want the grease leaking through the cardboard, so it was used in those types of food containers. And ski wax. I thought that was interesting. That's the first one. The second one is PFOS, and again, it has a 4 part per trillion drinking water limit, or MCL for drinking water. Again, Teflon pops up a lot. For PFOS, firefighting foam, and stain repellents. So like your Scotch guards, your upholstery protectants. Then there was PFH excess. So this is the third one. It has a 10 part per trillion MCL for drinking water. And this one was one that popped up for metal plating chemistry, for polishing agents, for paint additives. So it plays very heavily into the metal finishing industry. Then there was PFNA, which is a 9-carbon version of the PFOA. It plays a big part in fire suppression, foam control for fires, foam control in general, and cleaning and polishing compounds. And then the HFPO, DA, also known as Gen X chemicals. So Gen X chemicals were brought around as a safer alternative to the PFOA and PFOS. They're used in the manufacturing of fluoropolymers and again in different metal finishing compounds. So those are the ones that have MCLs. And then the EPA come back and said, if there's 2 or more of these present, you can only have 1 unit in your water. And they didn't put parts per trillion, parts per million. They just said 1 unit.
What is a unit, though?
They didn't really define that yet.
Okay.
That's where the drinking water limits stand as of now.
Like I said, a lot of communities who are treating this wastewater they're almost going to be mandated that they have to remove all of it. So it's, they're going back to their big customers, right? And this is kind of where the problem is coming from for the most part.
Right. So drinking water sources are generally where our wastewater streams go after treatment. They're then pulled in for drinking water. So drinking water, these limits came out this year. Wastewater in general, the municipal wastewater is expected to see limits in 2025. And so that's next year. And then by 2026, we expect to start seeing pre-treat permits have limits, which is where most of our industry comes in. So your direct discharge people, your municipal guys, they already are preparing for these limits. And they're expecting them to roll out in 25, and then they'll push back to the manufacturing industries to start removing them at that level.
From what I read is correct. A lot of wastewater municipalities, this is going to be hundreds of millions of dollars for them, right? To implement something. Am I correct in that they're pushing back on this because they're saying that they may not have the capabilities right now to, and I guess to put the equipment in for the wastewater treatment facilities at the municipalities would be $100-200 million for a lot of these, right? Is it that expensive?
Yes, a lot of the smaller rural communities, it will bankrupt them. There's no way around it. It will bankrupt a lot of these communities. So how does that tie into manufacturing? When you have a manufacturing facility that contributes 25% or more to the municipality, and in a lot of cases, it's the largest hiring center for that community, there is no other option. The municipality has to push it back to the manufacturing. So it's very chaotic right now. Anything I say today may change tomorrow.
Right. But things are going to happen. I mean, there's no question things are going to happen. A lot of people in the industry talked about how back in the late 70s, early 80s, the EPA mandated that they use these mist suppressants in their tanks, which contained a lot of PFAS and PFOA chemicals. Not too many people know. I mean, the electroplating industry basically raised the issue that these aren't really good chemicals to have, and eventually got the EPA to remove that mandate. But yet they used it, right? It's in their system. But talk about today. How does it get into a metal finisher's wastewater system?
So we're seeing some companies that say 100%. We've never used it. We don't chrome plate. We've never had chrome here. We've never used any. But when they test, they see that it's coming in paint additives. It's coming in rust preventatives on parts that are being shipped from overseas here to the United States to be finished. It's coming in their drinking water. So the tap water that they use coming in from the community, it is contaminated at higher levels than what we expect we have to treat for. And that's not uncommon in the metal finishing industry for our pre-treat permits to have a metal limit lower than what the drinking water that comes in and supplies the manufacturing process has in it.
For the most part, they're cleaning the city's water for them for a lot of parts.
Right.
They're doing it, right? Sending it back cleaner than they got it. But
in some cases, yeah, that is 100% the case.
I know this past year, the EPA did a huge survey of electroplating shops on their PFAS. What research is being conducted on how to remove PFAS? We hear things from time to time, and when I read it, sometimes I don't know what scale they're talking about. Sometimes I find out it's for an entire municipality. I haven't really seen a lot that would talk about how to remove it at the shop yet. But what type of research is being doing right now?
So interestingly enough, a lot of the research is focused on larger municipal plants, on the oil and gas industry, because that's where the money can come to supply the research. So like here at Hubbard-Hall, we're scaling those down. We're taking those research projects and we're saying, okay, how does that look for our customers? And is it affordable? So things like advanced oxidation, we're looking into bioaugmentation, different types of filtration, like and things like electrocoagulation. We're looking into all of these different options and investigating them. So it's interesting, though, that you talk about studies and research. The Water Research Foundation released a report last week that they did in partnership with a group called Carollo, Carollo Engineers. I'm butchering their name. But this was a multi-million-dollar research project that they initiated 2 years ago. And on August 6th, they announced that they had finished the project. They looked at where PFAS was coming from to municipal plants and to groundwater and surface water applications. And they found a pattern that held true across everywhere they tested. Groundwater was mainly contaminated from leaky landfills. Is the most common source of PFAS contamination. Leaky landfills. Wastewater systems, domestic sources contributed more than industrial sources, right? So, and then in surface water, pass through of wastewater systems, because wastewater systems can't remove it all yet. So that's where surface water. So I thought that was interesting that the industrial segment contributed less than your domestic sources.
Right. Yeah, that is very interesting, because you would think it's sheer volume, but it sounds like most people are cleaning their discharge pretty good. They're doing a good job at it. And something I just want to, they've called this forever chemicals, right? And that's wrong, right? These are not forever chemicals, so to speak. You're talking about destroying this.
Right now, there is only one proven method for actual destruction of the long chain, the carbon chain, that makes these considered forever. So yes, we can destroy it with advanced oxidation. Advanced oxidation uses a peroxide and an activation source such as UV light or an iron to accelerate a process where it actually goes out and scavenges the organic compounds and chews up those chains. It's based on something called Fenton's reaction, which was discovered a century or two ago. And it's very interesting. The downside is it's a slower process, and it's fairly expensive as peroxide prices are up right now. So that's the only known way for destruction. There are ways to remove it.
Okay, I know a couple shops that have put in carbon filtration systems and things like that. Very expensive, at $500,000 to $600,000. I mean, it's very expensive to do that. And like you said, I know that Battelle Institute in Ohio has like you said, ultraviolet and these type of things. So, but yeah, it can be removed. Now, again, at the cost and how efficient is another question with that. But like I said, you all are doing a lot of work with the metal finishing. So just kind of give us an overview. What are you all doing to help the metal finishing industry kind of start with this, with the PFAS removal?
So we partnered with a couple of different companies to look at alternative treatment methods. We kicked off our testing procedures at the beginning of August. We got our first test results back. So we were looking at traditional wastewater treatment, which is just add a coagulant, pH adjust, add a metal precipitant, flock it out, settle it out. Those are the first rounds of testing we got back. And so I'm going to share this with you. I can't obviously tell you just the facilities. But
Right. Okay. Yeah, we do.
the three biggest contaminants that fall under the PFAS. So first, let's back up a second. We used test method, EPA's test method 1633, which tests for 40 different compounds. And we found three that were pretty high. 62FTS was the first compound. And this is chrome mist suppression systems use this compound. Pre-treated, so untreated wastewater coming into, and this is shop does have hexavalent chrome. Untreated, they had a 0.049 part per million untreated. After their traditional treatment process, they got that number down to 0.03 part per trillion.
Wow. Okay.
So just regular treatment. Then there was another compound, PFBS, which is used in surfactants. So it's used in cleaners. Untreated had a 0.059 part per million. And after treatment, we got it down to 0.013 part per trillion. So it's a pretty big. So for the PFBS, this facility had a 0.059 parts per million, which in conversion is 5,900 parts per trillion. The EPA drinking water limit is 4 parts per trillion. Okay? So after treatment, we got it down to 1,300 parts per trillion. So even though we're not quite there yet,
getting closer.
So traditional treatment got them a huge chunk of the way. The third compound is the overall PFOS, and we took them from 4,300 parts per trillion to 2,300 parts per trillion. So we are seeing some reduction in just general wastewater treatment. Could this company then put in a carbon filtration system to clean that water up even further and make limits when they come out in 2026 if the funding is available? Possibly. So our next round, and that's just one company. So that's our next round of testing. We'll be looking at things like deionization. How does it impact it? Evaporation, does it impact it? Carbon filtration, does it impact it? And different microfiltration units, RO units. So once we now know chemically we can do some removal. Can we optimize that? Can we continue to build on that and get better removal if we add a UV light to them and a peroxide source? Could it help them remove even better? What does RO unit look like? And if we chemically treat to a certain limit, how far down do we have to chemically treat? And where is that cost-effective balance, right?
Is this existing products you're using now, or is it products that are under formulations that you're testing out?
So this company, 100% existing. The numbers we went over, that is 100% existing products that we're using now.
Yeah, it's quite interesting because it could be something that, like I said, whenever they do impose numbers, like I said, I know the EPA took the survey of 2,000 shops earlier this year. Lord knows when they're going to present the results. I've reached out to them many times. They don't talk to me. But, and determine what they're going to do with that, whether they're going to impose. Because really, the EPA has targeted the electroplating industry as one of 8 that it's going after with these regulations. So, but it's good that, like I said, you guys have made, seems like tremendous headway on, this research. That's very positive in that regard. Then.
Like I said, a lot of the research is going toward municipal treatment, toward landfill treatment, toward the textile industry, because they're heavily laden in it as well. I don't see a super ton of research going into metal finishing yet. But I think we need to. We have to. We have to be more aware of where we're at now so that we can understand how we need to get to where we're going to be when the EPA does put pre-treat limits on these compounds.
Well, like you said, it's simply, the next couple months to 12 months to a year and a half is going to be real, I think, impactful on the metal finishing industry if these new rules come to fruition. What they could be imposed upon them, and then, like you said, so I think it would be important for a lot of shops who, again, I think they're taking this very seriously. They don't know really where to turn because, like you said, there's not been any identified procedure they can put in their facility that would help them with this yet. And so they're waiting for EPA and they're waiting for the technology, which sounds like, again, you guys are making some headway, which puts a little bit of a light at the end of the tunnel, a dark tunnel, we should say, right, with that, because it is something that, like I said, I think everybody, they want to do. They want to do their part with that, but it's just got to be, like I said, the technology has got to be there, correct?
Correct. And not just for how to remove it, how to treat for it. The technology on how to successfully test for these parts per trillion range isn't up to par.
Is that nano? We're talking about nano levels, right? When we get to trillions?
Yes.
Right. Yeah. Which somebody was explaining to me one day that I forget, 1 part per trillion was an eyedropper being put into a Olympic swimming pool.
Yes.
That's what the equivalent they were telling me that this would be, which was astounding to me. But, it's almost beyond below trace levels to a certain,
yes,
with a lot of places, right, with that. Well, that's very interesting. And like I said, I know you guys will continue working on it and keep doing the research, which, like I said, the industry very much needs. But Robin, I appreciate that. We should definitely get back and talk again when things change, which could probably be within 48 to 72 hours, it seems like. But we should definitely come back, especially when you get more results on this. And, maybe we could put together a nice paper that kind of just, even if it's preliminary, just kind of gives people the, kind of a window of hope, because I think a lot of them just don't know what they could do until they're going to be told what they could do. But it'd be great if they could start looking at this. So
I agree 100%.
Yeah. Right. Yeah. And like I said, even if any shops want to kind of maybe contact you and volunteer, come do testing at ours, that might be a good idea to get as many different ones as you can with that. So reach out to you and like I said, I'm sure you'll be able to talk with them and when the technology's there, then be able to help them take care of this, because I know it's, like I said, the tremendous worry on their part.
Definitely. And what we've agreed with the shops that have agreed to this testing so far, just to put it out there, is this is a blind test study. The lab that receives the samples for testing only knows it comes from us. They give us the results, and then we send it to the shop. We don't, and we don't advertise. Like I said, I can't tell you the names unless the shop comes forward and says, absolutely, you can share our name. I know, but there is a lot of concern around what if we do have it, and a lot of it. How are we going to be viewed?
There is that stigma that comes with that they've done something horribly wrong. And then, like I said, it's just not the case in this situation with that.
Absolutely not the case at all. I did want to briefly talk about the lab we're working with, because I'm very excited about this. The lab we're working for is a relatively new lab that's doing all of our testing. They're working on putting in-line PFAS testing for wastewater effluent. And you might say, well, Robin, how can they do that?
How can they do that?
Yeah, they are using biochemical reactions. So based on how the bacteria and the enzymes react to the wastewater, they can detect different contaminants. And they test the EPA method as well, but because they're in the design and proof of concept stage right now. But I thought that was so fascinating.
That is very interesting. In line, yeah. I mean, a step better would be for these guys actually to test even the parts that come in before they even put them in their tanks and start washing them. That might be something down the road that they could, say to their customer, hey, we can't take these, these have these in there. But interesting. And like I said, always evolving, always changing, but it is certainly top of mind. So Robin, thank you. Like I said, we got to have you back very soon as this information changes for us. But thank you for joining us today.
Thank you, Tim.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.